Hey, are you interested in learning? Check out our videos. Want more knowledge content? Make sure you've subscribed to our channel.
In this video, we will learn how to deploy AI agents on Kubernetes and how to set up continuous monitoring and CI/CD pipelines to keep them running efficiently. Deploying AI agents on Kubernetes allows you to scale your workflows, manage resources effectively, and ensure that your agents are always available for real-world tasks. Let us start by understanding why Kubernetes is a great choice. Kubernetes is an orchestration platform for containerized applications. By deploying your AI agents in containers, you can isolate dependencies, simplify updates, and run multiple instances efficiently. This is especially useful for AI agents, which may require different versions of models, libraries, or tools. The first step is containerization. Conceptually, you package your AI agent and all its dependencies into a container image. This ensures that the agent behaves consistently, regardless of where it is deployed. You do not need to worry about operating system differences or library conflicts, because the container contains everything your agent needs. Once your agent is containerized, the next step is creating Kubernetes manifests. These manifests define how your container runs on the cluster, including resource allocation, networking, and storage requirements. You will also define services that allow external systems or users to communicate with your AI agent. Conceptually, think of this as telling Kubernetes exactly how to manage and expose your agent. Next, we move to CI/CD integration. Continuous integration and continuous deployment pipelines help automate the process of building, testing, and deploying your AI agent. For example, when you update the agent's model or logic, the CI/CD pipeline automatically builds a new container, runs tests to ensure everything works, and deploys it to your Kubernetes cluster. This automation reduces manual errors and allows for frequent, safe updates to your agents. Monitoring is another critical aspect. Running AI agents in production without monitoring can lead to unexpected failures, performance issues, or resource overuse. Kubernetes provides built-in metrics for CPU, memory, and container status. You can also integrate tools like Prometheus and Grafana to track more advanced metrics, such as task completion rates or error logs. Conceptually, monitoring is like giving your agent a dashboard that tells you how well it is performing and alerts you if something goes wrong. Scaling is where Kubernetes truly shines. If your AI agent is handling multiple tasks or serving multiple users, you can scale the number of agent instances up or down automatically based on demand. This ensures that your system is cost-efficient, highly available, and capable of handling peak loads without human intervention. Finally, security and best practices are essential. Keep sensitive credentials, API keys, or model access tokens secure using Kubernetes secrets. Always follow a structured approach for resource limits, network policies, and role-based access control to make sure your AI agents operate safely and reliably. By understanding these principles, you can deploy AI agents on Kubernetes in a way that is robust, scalable, and maintainable. You will gain a system where agents are automated, continuously updated, monitored for performance, and ready to operate in production environments. Mastering this skill opens doors to building enterprise-grade AI workflows and automation systems that are future-ready.
How did you feel? Is it helpful? Appreciate our efforts in the comment section below. Hit like button, share with your friends about us, subscribe our channel to get further updates. Stay connected with us on social networking sites. For more free tutorials, visit our website www.lanetguide.net.